Okay, so now we move on to the plots. I clean up my kernel. I set the console to the current working folder, and I believe I can just come in here and query the database which I already created and get ready to create a stack plot. So the first thing we're going to create is a stack plot. So let me show you what a stack plot looks like. This is what a stack plot looks like. It basically stacks data on top of one another. So wells 1, 2, 3 are in blue, orange, and green, and the data for each one is put on top of each other so that this point here, which is 2500, corresponds to the sum of all three. And the function that creates it is called stack plot function here. These are the parameters or the arguments of the function. First argument is the x-axis, and the other arguments are the data you want to stack on top of each other. And in this case, I'm stacking the data from three wells 1, 2, 3. So I set the well IDs manually to 1, 2, and 3 here. And we're using the read SQL query command from pandas with the F formatted string. So select the time, the rate, the cumulative production, historical, and also the cumulative production from the model we created from lab 11 last week from the rates table, right? Where well ID equals whatever well ID we specified here. And we do that for well ID set to 2, well ID set to 3. So we basically grab the time, rate, and cumulative production for wells 1, 2, and 3 and stored in those three data frames respectively. We also store the labels as well, 1, 2, 3, and that's what gets displayed here because we specify that here. And I already ran these three and it gave you the stack plot. So basically that's how you generate your stack plot for your lab 12 assignment. You will be doing this in a loop and I'll be showing you how to do that, what changes. But for now, we move on to stacked bar graph. So for stacked bar graph, let's run it again to see what it looks like. So this is what it looks like. Very similar to that, but instead of it being continuous, it comes in bars, and you're still stacking up data on top of each other. So n equals 12 is just a variable we created to be the number of bars you want. So we create an index going from 1 to 12, right? So n plus 1 takes it to 13, but we know a range won't get to 13, so it's going to be 1 through 12. And we're going to set the legends, the x-axis, to be the months starting from January to December. The width of each of these columns, we set it to 0.5. That creates some space between the bars. These are the three data sets we want to plot on top of each other corresponding to wells 1, 2, and 3. So they're basically plotted with the bar function. So how does it know where to stack the production on? Well, you just need to specify the bottom of each of those data sets. So the bottom for the well 1 production data is 0, right? Because it starts from y equals 0 for the blue. But the orange starts from the top of the blue, and the green, the base of the green starts from the top of the sum of the orange and the blue. And that's basically what is done in the function. So first argument is always time, and that never changes for all three. It's just going from 0 to 11. Then for the blue, like I said, it starts from 0, so you don't need to tell it the bottom. It's already 0. The width, of course, is what we said to be half of, basically, the space between the bars is the same as the width of the bars. So, important thing, you just specify the data set. For the second one, you specify the data set for well 2, but there is one extra argument, which, like you can already guess, is going to be the bottom. And that bottom is the top of well 1. And the top of well 1 is basically data coming from well 1. So data from well 1, which is precisely this. So this is the bottom for the second well. How about the third well? It's going to be the sum of the blue and the orange, and that's what is done here. You see that? So data frame 1, which is well 1, plus data frame 2, which is well 2. Add them up, and again we are dividing by 1000 because we choose to show the unit in m barrels, which is 1,000 in thousands of barrels. So that's the main thing. They are just multiple bar graphs. Each one starts from where you specify it, and you specify it using the bottom argument and provide the data as needed. And the legend, I mean, these are standard plotting functions. And again, I'll show you how to do this in a loop for your homework or your lab assignment. Another type of plot is the primary and secondary axis. So in the lab assignment, I ask you to plot rates on one of the axes, I believe on the primary axis, and cumulative production on the secondary axis. So this is precisely how you do it. And this is what it looks like. So primary axis is this, which is production rate. Secondary axis is this, which is the cumulative or production rate. So this primary y-axis, secondary y-axis. And the use of ax1 and ax2 is what makes this possible. So ax1 will be the primary axis, ax2 will be the secondary y-axis, and ax2 is obtained from ax1 by using the twin x function. And again, ax1 came from PLT, which is matplotlib.pyplot subplots. So you just need to provide your x axis, which is the same. Then for your y axis, you provide what you want. For the first one, we want rates. For the second, we want cum. And you can customize the colors as you would like. You can set the axis for the two different. So x label is time. There are two y labels, right? One is the primary, the other is the secondary. So ax1 for the primary, ax2 for the secondary. So production rate, that goes here, cumulative of production, that goes here. So basically that's how you generate your primary and secondary y-axis. And now I want to show you how to do these three in a loop, because we're going to be doing it for all 17 wells. So you're not going to copy and paste well 1 through well 17. That would be inefficient, and I will subtract lots of points if you do that. You're also not going to type well 1 through well 17. We're going to do it in a loop, which is why we learned loops previously. So I'm going to clear this and move over here And now this is actually the solution to your Lab 12 assignment, but I'm not going to give you all of that. I'm just going to show you the important parts, what is new. So for this problem, you're given the database here. So you're not going to create this database table. It's already in there. So you just need to use the read SQL query command to read it up. And I'm going to run it in batches too. So run this. It creates your plots with production rate on the primary axis, cumulative production on the secondary y-axis. And how do you do that? With the TwinX stuff we just talked about, right? TwinX function, ax1 for rates, ax2 for cum production. That's pretty straightforward. No traps here. I guess the important thing is the identification of the gas rates. Actually, no, not for this problem. This problem just wants you to plot all 17 wells. So you start from 1 and you go to 18 less 1, right? So you go to 17. So that just plots everything, and that's what you see here. Second question asks you for gas rate as a stack plot. So just the gas. We already know there's going to be 5 gas wells out of the 17 wells. So how do you query just the gas rate? We use SQL select command. Select well ID from DCA params table where fluid is equal to gas. So to make it clear what we're doing, I'm going to close this database and open that database. And I believe that database is in a different location, which you'll be here, and you go up. No, it's not here. So it's going to be more work. Okay. It's here. This is it. So there is the fluid column, right? And that's gas, 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 and gas. So wells 9, 10, 11, 13, and well 1 are the gas wells. So we want to select only those well IDs. So select well ID, meaning just this column where fluid is equal to gas. So it's going to restore only 1, 9, 10, 11, and 13. And you can double check that if we run just this. DCA data frame, so here. So that's exactly what you get, 1, 9, 10, 11, and 13. How about the previous line? Previous line is just removing the rate and the cum from the production data frame. So you specify what you want to drop. So data frame.drop, specify the column headers for the columns you want to drop. Axis equals 1 because you're dropping columns. In place equals true so that it removes it completely. We discussed this at the beginning. If you don't set this to true, it removes it for display purposes, but if you try to access the data frame, it puts it right back. So that's the important thing. And after running that, what you get is just time, because we need the times, right? Then we'll begin to store the well rates on new columns to the right. That's the general idea. And that's what we're doing in this loop. So well, concatenate it with the well number. So well 9, basically, where are the wells again? They are here. So we will say the next column will be well 1, then well 9, then well 10, and we are concatenating that using this for loop. So I will first be 1, then it will be 9, then I will be 10, and it's concatenating that with well. And you will see the result of that when we run this loop. So if I run this loop, so it created well 1, well 9, well 10, all through to well 13, and those are your 5 gas wells. How did it get the data in there? From the read SQL query command, f string, select the rate, just the rate from the rates data frame where well ID equals the well ID. So we're systematically querying this whenever the well ID is equal to those well IDs we're interested in. So well 1 was there, so it grabbed all of this, then it skipped all of this and went to well 9 and grabbed the rates, right? Went to well 9, which starts from here, and grabbed just the rates and pasted that in the corresponding column. So that's how that works. So select what you want, which is just rates this time around, from what database table, where, and you specify the condition. And now we grab the production rates, we store it in a production array, and grab the time, store it in time. So these are NumPy arrays, right? Dot values will take your data frame and convert it into NumPy arrays. Same here. So grab the time, store it in times array, grab the rates by starting from 1, right? So you remember Python starts from 0. So 0 contained the time. Everything else was rates. And now those two are sitting in your production and time NumPy arrays, and we're going to plot those here. So this is how we get the stack plot. This is pretty straightforward. Go grab the column headers, and you can see it here. We know the first is time, and we're not interested in time, so we'll remove that by starting from 1. If we don't specify the end, it goes to the very end. Then convert it from this weird data type to a list. And when you run that, you can also print it here, and you get this, right? So time has been removed and it's now a list. And this is precisely what I had showed before. Only changes: before we manually type each of the columns here, but we can't keep typing this if we have 20 columns, right? So the data is already stored in this array. Let's look at it. So this is what it looks like. It's an array, right? So no headers, no column headers. This is for the first well, second well, through to the 5th gas well. But it turns out this function doesn't want the data in this format. It wants it transposed. And what is transposed? I'm going to show you that right here. So this is the data originally. To transpose it, you can copy it, and in Excel, you can right-click, paste special transpose, and it transposes it, meaning data for well 1 is now going along the columns instead of going down the rows. Excuse me. So that's pretty much what you're doing with the NumPy transpose function. Transposing the data, because that's the only way this function works. And that's pretty much it. So instead of providing so many of these and specifying one after the other, which is not efficient, just transpose all of your data and you get this. And I'm not going to talk about oil, because you just need to query where it's oil instead of gas. And this approach still works. How about the stacked bar graph? So that was stacked plot, right? Here we want the bars. I wanted 6 months instead of 12 months, so you specify the months like I showed before. All of this is identical to what you had before. The only thing is we're using this result NumPy array to facilitate the calculation of the bottom. So maybe I should plot it first so it's easier for you all to follow. So this is what it looks like, right? There are 5 of them. So the blue starts from 0. Result is already set to 0. So we'll keep increasing results by adding the blue to the orange to the green in steps as you go up the plot. So for the first one, result is 0, and that's what you get when you start out here with I being the first well in the DCA data frame. So it goes through this. You use the bar plots just like we did in the single, just like we did here, right? Except we typed it out 3 times. Here you only need to type it once because you're in a loop. So the second time is going to be doing this and all. So gives you the first one. The bottom we set it to result, which was zeros, right? The first time. We can get the well ID from I, right? Concatenation, same as before. And we plot the first one. Then when it gets here, it's done, right? Remember, in Python, the index signifies, the space, the indentation tells you that all of these lines are within this for loop. So you're done the first time, then you go and set I to the second well ID. And now result will be here. So it's numpy.sum split, which is basically the cumulative production from the previous result, right? And that's this use of J makes that possible. So J was originally 1. Because we've gone through the first time, J is now 2. So it's going to go from 1 to 2 in the cumulative production data frame. And what's 1 to 2? This is 0, right? 1 is well 1 production data. That will be the bottom for well 9, right? For well 10, you will have to sum well 1 plus well 2 to get the bottom for the stack plot for well 2, which is the green. And that's basically what you're doing with this construct. So J is 1, the first time is 1 to 1, which is going to be this data frame, and that will be the bottom for well 9. And for well 10, you will sum 1 and 9 and basically keep going. If you have questions on this, we can discuss it during the class on Wednesday or Friday. And that's pretty much what we do here, and that allows us to generate the plot shown here. And you do the same thing for oil. And that will be it for this video. There will be a part 3 on logs.